Hello everybody, we are live. Welcome to another Jakarta Tech Talk. Today's topic is autonomous multi-cloud serverless deployment and optimized management. We are lucky enough to have joining us today from AI Investments, Paweł Skrzypek. I'm not sure if I got that right or not, Paweł, but apologies. Almost. Close enough. Paweł is the Chief Technology Officer at AI Investments, and also joining us is Alicja Reniewicz. She is the full stack engineer at Seven Bulls. At this time, I will turn it over to you, Paweł and Alicja, and take it away.
Okay, thank you very much, and thank you for the invitation. As Hudson said, today we will present the work which was done in the Melodic project and is currently continuing in the Morphemic project. And the outcome of this work is the complete platform for autonomous multi-cloud deployment and optimization, including serverless components. The presentation will be split into the two parts. The first part are a couple of slides with some information about the projects, platforms, and what we have achieved and how it works. And then Alicja will present the live demo, how to deploy the application and how to use our system. So we will try to have around the 25 minutes for the slides, and the rest of the time will be live demo. If you have any questions, please ask on the chat. We will try to answer them simultaneously during the presentation. Also, I hope that we will be able to have some Q&A session at the end. Okay, let me. How I should. Okay. The only issue is that I can't switch a slide, which is a very strange thing. One moment. Okay, let me share it again. It's very strange why I can't change the slides. It should be here. One moment. Okay. Oh, now it works. Okay, I hope you can see the second screen, the second slide. What is Melodic? Melodic is a very unique, and I think that the one of the very innovative solution which allows for the multi-cloud deployment. So it is the one platform, one tool, which automatically deploys application to the different cloud providers, but not only deploy, but also allows for the optimization of the resources used by application, and it is done on the initial deployment and continuously based on the current use of the application. So Melodic initially select the best resources and then continuously monitoring the deployed application and adjust the configuration, adding or removing resources, or even move the application to the different cloud. And how it is done, I will show that during the presentation, and I'll show it live. Yeah. A very important thing about Melodic is that it's a fully open source, so all source code is available. It could be downloaded and used for free, and we are still developing the Melodic platform. As I said, it was originally created in the Melodic project. It was the project research and development project under the Horizon 2020, and current development of the Melodic project, the Melodic platform is done within the Morphemic project, which is also the research action and innovation action during under the Horizon 2020 project. So, why to use Melodic? The most important feature is that Melodic is probably the simplest and easy way to use the multi-cloud approach. Application is modeled in the Camel language, and then it is automatically deployed to the multi-cloud environment, and do not require any knowledge about the particular cloud providers. We can deploy to the AWS, Google Cloud Platform, Azure, and also to any OpenStack-based public and private clouds. Melodic can deploy virtual machines, containers, serverless components, and also big data framework like Spark to the mentioned cloud providers, and also it can optimize this deployment based on the current usage. As I said, the deployment is fully automatic, is done fully automatically, so there is no need to any manual intervention, but it could be verified by the DevOps or administrators, but the initial assumption is that it is done fully automatically. And yeah, probably the most unique feature of the Melodic is ability to automatically optimize the usage of the cloud resources, even more the usage of the multi-cloud resources. So based on our knowledge, it is the only platform which allows for the automatic optimization of the multi-cloud resources in the runtime. So the application is deployed, we are monitoring them and are able to add or remove the resources. On the further slides, I will say what it means that the best deployment, how this optimization is done, and what is the uniqueness of our platform, and also what are the topics which we're currently working on. But first step is to model the application, and we have developed the Camel language. It's an acronym for the Cloud Application Modeling and Execution Language. It is a language which allows us to model both application and infrastructure. So this is the first difference comparing to the other language cloud modeling languages. It is cloud agnostic, yeah? So it's not bind to any specific cloud provider, but allows for the multi-cloud deployment, allows for the modeling components, connections, security rules, and more as a model, and then these components, connections between them and security rules are deployed to the different cloud providers. Of course, we can model the infrastructure, but we are not specifying the exact infrastructure which have to be used, but we can define the requirements which are used by the optimization process to find the best possible deployment. And it is done by defining the user requirements. So for example, what should be the maximum, what is allowed the maximum response time of the given application, constraint that, for example, we want to have more than 4 virtual machines for the given component, and utility function, which is the very unique way to measure how good deployment is. I will also say a bit more about that later. And also, very important, we are able to translate this Camel model into the form of the constraint programming model, which is the set of the equation which defines the optimization problem, and this problem is solved by the platform to find the best optimal deployment to the multi-cloud environment. So What is the best deployment? There is no easy answer because for the different application, it could mean different. For example, for the e-commerce application, the response time to the user should be minimal or not bigger than a specified one. For the big data application, the jobs processing time should be minimal or no longer, and so on. Also, the cost should be as low as possible, and also other functional and non-functional requirements should be defined. And this deployment, the quality of the deployment is assessed on the runtime based on the metric collected by the application. Part of the Melodic platform is novel event management system, which allows for the multi-layer metric collections. So we are able to collect the metrics in the real time and to do the real-time aggregation. And thanks to that, we can collect metric from the hundreds of the virtual machines which are running through the different cloud providers, because we are not pushing all of the raw single metrics to the central point, but they are aggregated at the different level, at the virtual machine level, cloud level, and then finally at the platform level. So we are able to have the near real-time metric collection, which is very unique for the multi-cloud deployment, especially that our metric collection, metric aggregation is fully cloud agnostic, so could be deployed to the different cloud providers. We have the flexible way to calculate the utility for the particular application. So we can define utility which focus on the business value. So we can measure the CPU memory, but we also can measure the average response time to the user, or average time of the job processing, or any other business metrics, and our utilities, so deployment, could be based on that metrics. And the best deployment is always the trade-off between the cost, performance, availability. Of course, if we remove the cost from that utility, then we can use the best possible resources, and as many of them as possible. It will have the best performance, but the cost will be also the highest. Yeah, so the utility usually is focused on the optimizing the trade-off between the cost and other other requirements. And this deployment, this optimization is done fully automatically. So the metric, as I said, are collected in the real time and delivered through the multi-layer event management system to the central point. And in the central point of the platform, the very advanced AI-based solvers are continuously solving the problem and trying to find the best possible situation, the best possible solution in the current moment. Of course, we do only the reconfiguration only if the certain threshold are violated. It is called SLO violation, because in the other hand, it will be the continuous reconfiguration of the application, which is not exactly the desired business effect, but we want to have the best possible deployment in the current moment. So, how it works. First step is to model application in Camel, as I said, the Camel language. Then we need to set the initial parameters like requirements for the infrastructure, for the components, and so on. And then Melodic calculate the initial deployment. Based on the initial deployment, on the parameters set in the model, Melodic is looking for the best selection of the cloud resources and make deployment to the selected cloud providers. Then the metric collection is started and Melodic is collected metrics. If the metrics violates, certain metrics violates the SLO, Melodic is triggering the reconfiguration process, so the new deployment is optimized, calculate, and the new solution is found. Then Melodic automatically reconfigure the application, add the resources to the certain components or remove the resources. And it is done fully automatically in the safe way. So for example, if we want to switch component from the one virtual machine type to the another, then the new virtual machine is created. The communication is switched to the new virtual machine, and then the old virtual machine with the previous version of the components is deployed. We are fully support the cloud native deployments, so the application is the infrastructure and the application is created from scratch based on the model defined in the Camel language. Here is a very brief architecture of the Melodic. You could go to our webpage to get more documentation and more information about that, but more or less it looks like that. We are fully support the microservice architecture with the control plane using REST protocol and monitoring plane, which uses the active MQ for moving the monitoring metrics and values. So that's the Melodic platform, but it's not enough. We are working on the new, very innovative concept, which I'm pretty sure not available in the other solution. And yeah, I think that after developing them and creating that would be very, very novel approaches. First of this concept is polymorph architecture. So we want to be able to choose the physical architecture of the application. So to choose if we want to use the given application and deploy it to the virtual machines, or maybe serverless components, or maybe some hardware accelerated resources, and that will add the additional layer for the optimization. So the goal is to be able to maximize the utility of the application by choosing not only the number of the resources, but also the technical architecture of the application. And the second concept, which is currently developed by us, research and develop, is the proactive adaptation. Yeah? Because as I said on the previous slides, currently Melodic is adapting based on the actual current values of the metrics. We want to make a step further and try to proactively adapt it. So for example, if we will observe that the number of the customers for the e-shop or e-commerce solution is rising, then we want to proactively forecast that situation and make reconfiguration looking for the future. So not for the current values of these metrics, but the future one. Yeah, that would address the problem of the delay with the adaptation, because based on the current values, the SLO is triggered based on the current values of the metrics, and before the adaptation will finish, we have the period when the application is not fully utilized resources, and some of the metrics are not fulfilled, or threshold of the metrics are not fulfilled. But with the proactive adaptation, the goal is to be able to forecast the future and adapt to the anticipated workload. To do that, we are currently working on the most advanced forecasting methods, and we are trying to apply that methods to use with this proactive optimization and to look on the future. So our idea for the proactive adaptation is that it will work at the beginning in the similar way as currently Melodic is working. So there will be the initial deployment of the application, then the metrics will be collected, but the optimization will be based on the forecasted value of the metrics. So we are anticipating the future, not the current one. And the optimal deployment plan will be this one, which is optimal in the future, not now. And the reconfiguration will be based on that. Yeah, as I said, please visit our site, Melodic Cloud, or follow us on LinkedIn or other social media. There are much more information if you are interested. Also, the system can be downloaded and used, and how to use the system Ala will show on the next presentation. But I want to say to show two use case applications. One of them will be shown by Ala live. One of them I want to say because it is used by the AI Investments. So the AI Investments company is the active user of the Melodic and in future Morphemic platform, and it saves a lot of money. I will show how much money we can save thanks to the using Melodic. AI Investments is the company which is working on the machine learning and AI models for the portfolio optimization. AI Investments is using advanced forecasting and optimization methods for that. So this, especially machine learning methods, requires a lot of the computational power to train the models, especially that we need to train these models in a certain amount of time. And of course, we want to save the cost and minimize the budget. So one of the example of our business goal is to train 50 predictions models in the 1 hour using, of course, as minimal resources as possible. How it is done with the Melodic? Yeah, we are starting training. So this one guy, it's me. I'm not sure if you can see the similarity, but yeah, that's me or other analyst in the AI Investments. We are starting to train our models on our resources, on our on-premises resources, because they are the cheapest one, because we already own them. And Melodic is checking how long it takes on our resources. It looks that it's 3 hours, so it's way too long. So additional resources are added in the cloud, and they are, of course, selected to be the most optimal as possible. Melodic is checking that with additional resources it still takes 2 hours, so add additional resources, and with additional resources we are able to finish the processing in 1 hour. So after the finishing the training, all of the cloud computing resources are decommissioned. So Melodic is able to optimize it in the runtime and with the very good results. So I will maybe show the results. So in the 1 year perspective, we are able to have the savings in the 3 years perspective, our savings are at this level. Yeah, so we are able to save over the $170,000 comparing to the non-optimal solution. All of these savings are documented, so there are a detailed description how we achieve these savings using the multi-cloud optimization. And yeah, I think that using the novel features of the Melodic platform, which are developed in the Morphemic project, we will be able even to save more. And the second, maybe let's say more familiar example is Genome Application. It is the application which processes the genome data and compare that with the reference genome to find the mutation. It is the very typical big data application which is running on the Spark, and it works exactly in the same way. Yeah? So we want to process the given number number of the jobs in the certain amount of time. And we are starting with the minimal resources. Based on the speed of the processing, Melodic is calculated how long it takes and add additional crowd resources. Then again, check how much time it takes and add additional resources. So everything is working in the runtime. It is a very unique way to dynamically optimize the resources used by the big data frameworks and big data application. And thanks to that, Melodic allows to fulfill the business goals, for example, to process the data in the certain amount of time, and also to save a lot of money, really lot of money. So that's probably the best business reason to use that application. And now we will switch to the live session. Ala will show the Melodic UI and show the deployment of this Genome application live. Also, it is very possible that we can see the reconfiguration process. And in the meantime, I will try to respond all of the question, and I hope that we will be able also to make a Q&A session at the end. So Ala, if you can share your screen.
Yes, now I would like to share my screen, and okay, I hope you can see. Okay. In my part of presentation, I would like to present you how to automatically deploy own application by Melodic platform. I will perform deployment of Spark-based application. We will monitor application metrics and observe reconfiguration process, which is done by Melodic for reasons of optimization. My Melodic platform is installed on virtual machine on AWS, and it is up and running. I'm logged in. Melodic users are managed by LDAP. We have 3 possible roles of users. Common user, he can perform application deployments. Administrators, admin manages of users' accounts, and also has all privileges from common user. And the last type of user, technical users. Technical user is used only internally by Melodic components, and he is not important from client's point of view. The first step in Melodic usage is the defining of cloud settings. In provider settings menu part, we can check and update provider's credentials and options, as we can see here. Filling these values is required in order to perform successful deployment because they are used in contact with providers, for example, by creating virtual machines instances. On my environment, I have already defined 3 values for on my environment, I have already defined values for Amazon Web Service and also for OpenStack. In such definition, we need to provide cloud credentials and also properties, for example, settings for Amazon security group or set of private images, which we would like to use in our deployments. When our platform is properly configured, we can go to deployment bookmark. Today, I would like to deploy Genome Application, which was described by Paweł a moment ago. Before deployment, we need to model our application in a camel model language, which is human understandable and editable form. After that, such model is transformed by dedicated tool to XML format, a form understandable for melodic. We upload this XML file here. I have my genome model in XML format. And now our model is being validated, and after that it will be saved in database. In a minute, I will be asked for field values of AWS developers' credentials. Providing these credentials is required in order to save results of our Genome application in AWS S3 bucket. But in view of security reasons, we shouldn't put them directly in camel model file. So we use placeholders in camel file, and after that we need to provide these values here. In this case, it's not the first upload of such model on this virtual machine, so these variables already exist in dedicated secure store on my melodic machine. I verified them. Of course, I could update if they were changed, and after that I choose save button. Now I can see that secure variables and also my model are stored in database, so I can go to the next step. And here I need to choose which application I want to deploy and which cloud providers I want to use. Here is also possible to run application in simulation mode. Simulation mode is the case when we don't want to deploy real virtual machines on providers' platforms, but only check which solution will be chosen by Melodic. We manually set values of metrics in simulation part and observe the result. But today our aim is to perform real deployment, so I leave this option turned off. I would like to deploy Genome on AWS, so I choose these cloud definitions. Thanks to that, Melodic has credentials to this provider. And after that, we can go to the last step where starting deployment is available. After starting the process, in a minute, we are moved to the deployment process view, where we can observe the progress of that. In the meantime, I would like to briefly describe application which is being deployed by Melodic now. Genome is a big data application which performs some calculations and saves results in AWS S3 bucket. So we needed to provide developers' credentials to AWS. Genome's performance is managed by Spark. In Genome application, we use Spark as platform for big data operations, which are performed parallel on many virtual machines and managed by one machine named Spark Master. Spark Master is available by default on Melodic platform. Melodic creates proper number of Spark workers as virtual machines considered our requirements from camel model. Thanks to measurements of application metrics, Melodic makes a decision about creating additional instances with workers or about deleting unnecessary ones. Spark divides all calculations named tasks between available workers. In order to optimize application performance and cost. And now I would like to back to our deployment process. Fetching offers is the first step of deployment process. We have information about current total number of offers from previously selected providers, so in this case from AWS. From these offers, Melodic will choose the best solution for worker component. After choosing this box or offer options from menu, we are redirected to view of all currently available offers. There are clouds with my credentials, a list of available hardwares with information about cores, RAM, and disk, and list of possible location to choose by Melodic. Also, we have images list. Here we can see only private images, but of course all public images are available for us. The next step of process is generating constraint problem. Constraint problem is generated based on our requirements defined in camel model. In simple process view, there are visualized all variables from constraint problem with their domain values. For Genome, we have worker cardinality, worker cores, and provider for component Spark worker. Detailed data are shown after click on this box, and here are presented list of variables with additional information about component, type of this variable, and also domain of it and type of this domain. Utility formula. It is used for measure utility of each possible solutions and choose the best one. List of constants with types and values. They are created from user requirements and are used in Melodic calculations. Here we can see, for example, minimum and maximum value for cardinality of Spark worker instances, or the same type of restriction for number of Spark worker cores. So we can see that we would like to have from 1 to maximum 10 workers instances. And the last element here, metrics, with their type and values. They describe current performance of application. Thanks to them, Melodic can make the most important task, which is cost optimization. After, of course, a decision about triggering the reconfiguration process, which means creating new additional instances or deleting not fully used ones. And now we can back to our process view. When a constraint problem is generated, it is time for reasoning. Melodic finds here the most profitable solution for the problem defined by us. And when rezoning is completed, we can observe information about calculated solution, a utility value for each variables, in that case, one as worker cardinality, for worker cores, and provider for Spark workers from zero index. And the next step is and the next step in our process is deploying. Here, Melodic performs operations based on calculated solution. This solution is deployed for each application component. Melodic creates proper instances, remains them, or deletes. And here we can see that some problem occurred during our deployment. Unfortunately, we can check the problem in our deployment artifacts part. And here we can see each part of our deployment. And here we have our processes and nodes. Okay, so we have some problem with creating of nodes because they are not visible yet. Also, we can monitor our application in Camunda view, but I think that in such situation, when we have some problem, we can use our video of Genome in order to show you how the deployment should be done.
Yeah, that's the issue
Okay.
with the live presentation.
So yeah, in the meantime, I try to find it. Okay. So now I need to only check the screen, which are shared. So sorry for that. Okay, so for okay, I need to stop sharing for now.
Yeah, please check.
And yeah, I need to find the option in how to stop share the screen. Okay.
Now it works.
Yeah, thank you.
Okay, so let me make a quick sharing. In the meantime, I will tell where we are exactly now in the process. Yeah, so this is this process which Alicja follows. Yeah, so we have the model of our application. Then we need to have the Melodic platform itself deployed. And then we have to submit our camel model. And these steps are already done, and then starts the deployment process. And the deployment process is quite complex because we need to fetch all of the offers from the cloud providers, and it was done as Ala has presented. And then the best, let's say, most optimal resources needs to be selected. And then deployed. Yeah, so as we have said, the deployment is done automatically. As you can see, it was done automatically, and we can monitor which part of the application is currently deployed and what is the status. And the deployment is not just the deployment of the virtual machines, because in Melodic the deployment process is quite complex. We need to provision new virtual machine, container, or serverless component, and then on that resource, so for example, on that virtual machine, we need to deploy the certain components, but also some part of the Melodic platform, mostly the event management system, the props and sensor which are used to the monitoring application, and we need to do that in the multi-cloud way. So this is done on the all clouds in the very similar way. Yeah, so and we decide to show that real and live, but as you can see, sometimes some bad luck that something is not working, but let's give some time Ala to check that. And also, yeah, as I previously said, the Melodic is fully open source and could be downloaded under this link. So if our presentation, our platform is interesting for you, then you can go to our website, download, and try to use by yourself. There are also a lot of the resources, videos, documentation, some tutorials, how to use the Melodic. We are recording the presentation, and they are available then. And also, as I already mentioned, but yeah, it would be good to also follow us on the social media if you are interested. And I suggest to follow not only the Melodic project, but also the Morphemic project, which is based on the Melodic platform, but add additional very unique features like architecture optimization, polymorphic optimization, and proactive optimization to add that to the platform. Yeah, and we are very heavily developed the system, so it sometimes happen that something not works, but yeah, I hope that it would be manageable, and we provide the working version with many new features. Ala, should I give back screen to you?
Yes, please. Okay, so now, thank you. Now I show you how it should look like. I hope now you can see the screen with video of Melodic. So when our process is successfully done, we can see here information about that. Okay, and after that, we can observe the result of it also on Spark Master UI. As I mentioned before, Spark Master is part of our Melodic machine, so we can check on 8181 port how it works. And in such case, we can see information about available workers, running application, and drivers. And also, the important part of Melodic is monitoring of our application. This monitoring is done by Grafana. And I would like to show you the dashboard with available metrics. So, for example, here we can see metrics from Genome Application. Each application has own settings and own metrics, so also requires own own dedicated dashboard. And also in case of Genome Application, we can see information. We can see information about if we can finish on time or not, thanks to this traffic lights imitation. And also we have also we can observe how many minutes left from the time period under time left value. The expected time was indicated in camel model, and in case of Genome it is equals to 16 minutes. So for example here we can see that we have only 1 minute of performing this application and 59 minutes left. And based on current performance, it is calculated the estimated time left. On the left, on the first chart, we can monitor number of instances. In the bottom ones, it is presented number of remaining simulations. This value is decreasing with performing next tasks by arc. And on the right chart, named number of cores, we can see value of minimum cores needed to finish calculations on time. And also current number of cores under total cores value. And for example, in this situation, Melodic claims that we need at least 5 cores. Also, the estimated time is higher than time left. We can see red light. So they are signals that our application needs more resources. In such situation, Melodic makes a decision about triggering reconfiguration process. And after that, we can see in process view the information about this process. In case of reconfiguration process, the 2 first steps are not present because because Melodic doesn't fetch new offers and uses also the same constraint problem as for initial deployment. And for these reasons, the first step is rezoning. As a result, we can see new calculated solution which will be deployed. And in that case, Melodic claims that 2 workers will be needed. After that, this solution is being deployed. Also, we can observe the instances in AWS console. Okay. Now we can see that the second instance is available also in Grafana view. And after that, the time. Okay. After that, the deployment is finished, and we expect that after that, the time that our metrics should be better. Also, in case of Genome, in the first part of performing calculations, additional workers are created as far as Melodic measures that the effectiveness of application is too low. And in the final part of performance of Spark jobs, Melodic makes decision about deleting unnecessary instances when it is visible that application will finish on time. Okay, so unfortunately we didn't observe the whole deployment process and the reconfiguration process for Spark application because of some issue during the real deployment. But I presented you how it should look like in case when we haven't any issues, timeout problems, connections problems, and so on. So thank you very much for your attention.
Yeah, thank you. Thank you, Ala.
Okay.
Can you hear me?
Yes, we can.
Okay. Thank you very much. And yeah, we have 5 minutes more for the questions. I see that on the chat there are no questions. Maybe I'm looking in the wrong place. It could also happen. But please let us know if you have any questions. Can we say something more on the specific topics?
Yeah, it sounds like there have not been any questions yet. That just must mean that your explanation was so thorough that everyone got to know everything they wanted to know. But yeah, we'll leave a couple more minutes here to answer any questions if anyone has any last minute. But yeah, otherwise, thank you everyone for joining today. And I'm just going to post a quick link to the survey in the green button below if people watching would not mind completing that afterwards. It's always great to get feedback on how you enjoyed the session. Not seeing any more questions coming in here, so we'll give everybody a couple minutes back in their day. Thank you very much, Paweł and Alicja, for your time today. This recording will be available by the end of the day today on YouTube.
Thank you very much. Thank you for attending the session. It was the pleasure to be able to present here, and yeah, thank you very much.
Thanks, everybody. Bye.